Self-driving vehicles is getting smarter with this lots of sensors, and to provide road safety with a better recognition and decision-making and driving skill. Self-driving vehicles is getting smarter with this lots of sensors, and to provide road safety with a better recognition and decision-making and driving skill. We categorize the fault into two types, permanent fault and then transition fault. So we usually, in this talk, we focus on the error in the memory, and then the permanent fault in memory means it caused the application to crash or hang. And then it required the software reset to reset the application to recover from the beginning from the error. So let me give you a short example. So here we have a NVIDIA PX2, the small embedded system, and then it has a two chipset, a 2 DRAM chip here, and then we are running the 4 GPU applications, and then we have here the heat gun. So what I'm gonna do is I'm gonna give a high temperature to one of the DRAM chips, and then see what happened to this GPU task. So GPU task is executing and then they start crashing, but it's not crashed. It doesn't crash the system. It only crashes the system software. We need to reset this application to start from the beginning. So what about the transient fault? Transient fault is the random and temporary error in memory, such as bit flop. So 1 goes 0 and 0 goes to 1, and it usually causes the wrong detection result. For example, so if we inject some random error, it can have a false positive like this, and then part of the detection result, and sometimes it detects more than the objects, and then sometimes it creates the false negative misdetection, and then sometimes it can detect human as so far. So this is the pipeline for CNN. So CNN, as you see here, it takes the image and then it extracts the feature using the convolutional kernel, and then it passes the next layer and to extract another feature, and then this feature extraction go on and on according to this the convolutional kernel. So how can you overcome transient error? So we propose this partial duplication-based recovery. So important thing is that how can we know what is the important part of convolutional kernel? What is the important part of the neurons into the network? So we define the score as symbol as score. So for example, we can actually define the S using the sum the older values into the given kernel, and then use this value as to rank the kernel, rank all the neurons. For example, like the higher sum of the weight is better, might have a more impact for the detection result. So this is called a weight sum ranking, and then we took only the top two, for example, here, and then duplicate that kernels and then feature maps. So here is the small the experiment. So once you select the rank, once you select the important neurons, it's a one-time offline calculation, and then we inject the random transient error using bit flop, and then to cause this kind of problem as you saw before. And then we measure the accuracy using the different types of the ranking method according with respect to the error. So x-axis represent the different percentage of error, and y-axis we measure the accuracy. So please take a look at this blue and then green line. The blue line represent the accuracy goes to significantly drop without any duplications. And then for the green is we rank the applications neurons, and then using the weight sum ranking policy. And then we saw that with the 6% error, it still provide a 55% accuracy.